What is algebra? In this section, we'll look at a bunch of definitions and terms you'll encounter when you're doing algebra. First, arithmetic. Arithmetic is the study of numbers and the basic operations, so plus, minus, multiplication, division between them. Once you start talking about algebra, you're introducing an unknown. So this unknown is typically represented by what's called a variable, and the variable is just a placeholder for some unknown value. Usually the symbol is any letter from the alphabet. Typically X is the first one you choose. And even though we have unknowns, we can still do arithmetic with the algebra. For example, arithmetic on the left, 1 plus 2 is some unknown. When we want to start talking about that as algebra, we'll say 1 plus 2 is equal to some unknown value x. And then the idea with algebra is that you're going to solve for x. You'll do arithmetic when you're doing a calculation, but you're not necessarily doing algebra then. But if you're solving a problem for an unknown, you're going to be doing arithmetic with the algebra. A basic algebraic equation is a mathematical statement where the left-hand side is equal to the right-hand side. They might look different, but they are exactly the same. So we can use the rules of arithmetic and rearranging in order to solve for an unknown. So finding the value of the unknown x is the same thing as saying we're going to solve the equation. So in this particular case, we had 1 plus 2 is equal to x. We do the arithmetic on the left, 1 plus 2 is 3, and then x is equal to 3. So that has been solved. Once again, a variable is just any letter that is representing an unknown number. Typically, there's x's, y's, a's, anything from the alphabet. A term is a combination of numbers and variables that can be multiplied and/or divided together. Importantly, what separates a term is a plus or minus sign. So once you start seeing addition and subtraction in an equation, you start seeing multiple terms. And overall, these combinations of terms are referred to as an expression. Now, for any term, we can be talking about coefficients. Coefficients only refer to the numbers in front of a variable in a term. So for example, 5x, the coefficient is 5, minus 7y, the coefficient is minus 7, and for 2, well, there's really only a coefficient there, and we would just say it's 2. And constants are terms only containing a number, so there's no variable in there. So the 2 that we saw in the last example is an example of a constant. Now, you can't do algebra without talking about like terms. Like terms are very specific because you cannot add or subtract a term unless the combination of variables and the powers on those variables are the exact same. For example, with the terms x squared, y, a cubed, a squared, 3y, and x, there's only 2 sets of like terms there, and that's the y and the 3y. All of the other terms have a different combination of variables. Even if you have 2 x's, that's not the same as only having 1 x, or having 3 a's is not the same as having 2 a's multiplied together. You have to be very careful when adding together or subtracting your like terms because it's very easy to make common mistakes. Starting with monomials. This is just an expression with one term, so you won't see any pluses or any minuses in a monomial. Once you start talking about binomial, that means there are 2 terms because bi means 2. So you'll see 1 plus sign or 1 minus sign, and then any combination of those terms in between. So you can see lots of multiplication, lots of division, but you'll only see 1 plus or 1 minus sign. For a polynomial, the word poly means many. So a polynomial means an expression with 2 or more terms. So you can see more than 2 additions or more than 2 subtractions or a mix of the 2. So for example, you'll have 8x squared minus 5x plus 3, and you have 3 terms in that expression. One key aspect of a variable is that even though it represents an unknown, that unknown can only have one value. If you're using x the same time twice in an equation, that x needs to represent the exact same thing both times. So in an equation like x plus x is equal to 10, you can't say that one time x was equal to 6 and the other time x was equal to 4. This doesn't work out. They can't take 2 different values. So the only way you could solve this equation is by saying x was 5 both times. So 5 plus 5 is equal to 10. That's the only way that can work. So if you see something more complicated, such as this, 30x plus 6x divided by 2x is equal to 3x plus 15 over x, each one of these x's all represents the exact same value. And really, because of that fact, that's the reason why we're able to isolate for x and then eventually solve for it when we're doing the algebra to solve for the x. When it comes to writing down your operations, there's one change that you start to see when we do algebra, and that's with multiplication. So if you're doing addition and subtraction, you still write the plus and minus sign. If you're doing the division, you're still going to write the division, although often you'll see the division written in terms of a fraction. However, you stop writing down the x to denote multiplication. And the reason there is pretty obvious, because if you're using x as a primary variable, you shouldn't be using another x to mean multiplication. So typically we just leave that out and we can write it with just nothing in between. So if you see AB, that means A times B. Or if you were to see 2x, the coefficient just tags along with the x and it's just 2x, and you leave out the multiplication. You can see how that above expression already looks quite complicated because there's two different styles of x's there. So you can also see if you have more than one variable, you just push everything together as 3, the coefficient, and your variables a and y. And remember again that division is usually written in terms of a fraction. So remember, this rule change only applies to when you're multiplying a number with a variable or two variables together. If you're just multiplying numbers together, you do still need the multiplication in between. You can't just write 2 times 5 as 25. But what you can do to adopt a similar style is to use brackets in between. So you could write 2 times 5 as 2 in brackets with a 5, or 2 in brackets with just the 5, or the 2 with the brackets on the 5. All of those three expressions still give multiplication, and it looks more similar to an algebraic expression. And again, it solves that problem of not having two x's, one to denote multiplication and one to denote a variable. This same bracket notation can be used if you want to multiply two expressions together. They could be binomials, like in this case, where we can write a plus b times x plus y without the multiplication in between and just push them together with the brackets. Multiplication is implied.